Now we look into the insertion sort. In this sorting, given array consisting of n number of elements, we can sort the array either in decreasing order or increasing order. If we want to sort it in increasing order, from the second element, we leave the first element as it is, and from the second element, we compare it with the predecessor. If it is having its in, if it is in the right place, then we leave it and move on. If it is not in the right place with respect to the increasing order, then we swap it with the predecessor. So it being the second element, we compare it only with the previous element, the first element. If this is greater than the first element, we swap it so that this reaches the first position and the first element becomes the second one. Now, the third element will be compared with the immediate predecessor. Again, it will compare it with that. If it is less than that, we swap it with that. This swapping will continue until the third element reaches its corresponding position in the sorted subarray on the left hand side. So the first three elements are now sorted, and fourth element again will be compared with the immediate predecessor of the third one. Again, if it is greater than that, we leave it. If it is less than that, we swap it. Again, we'll keep on swapping until it reaches its position in the left subarray. So like this, every element will compare with the predecessor and keep on moving this, swapping with this element in the left subarray until it reaches its corresponding position in the sorted subarray on the left hand side. So gradually, starting from the left hand side, the subarray on the left hand side will be keep on sorted order, keep on in the sorting order. So this is how it progresses until we reach the last element. Why we call it as insertion sort is every element is inserted in its corresponding location. That's how we can look at this. So gradually this grows, sorted subarray grows until the entire array is sorted. Now we look into an example here. The array consisting of 7 elements. So the first element is 8. We leave it as it is. We start with the second element 4. We compare element 4 with 8. It is being lesser than 8. We swap it with 8. So that 4 becomes the first element and 8 becomes the second element in the sorted subarray. Now by this time the sorted subarray is 4 and 8 and all the remaining array is unsorted. The third element is 6. Now compared with the immediate predecessor 8. So 6 is less than 8. So we'll swap it with that. We don't stop it here. 6 will be compared with the again immediate predecessor 4, and 6 being greater than 4, no swapping is done. We'll stop it here. So by this time 4, 6, 8 is the subarray which is already sorted. Then the next element is 3. 3 is compared with 8. Swapping is done, and 3 and 8 will be swapped. 3 will be compared with 6. 3 is less than 6. Again will be swapped. Again 3 will be compared with the predecessor 4. 3 is less than 4. So 3 will be swapped with 4. So like this, after all the swappings are done, 3, 4, 6, 8 is the sorted subarray, and all the remaining part is unsorted. Next element is 1. Again 1 will be swapped with 8, 1 will be swapped with 6, 4, 3, and 1 will be finally swapped with 3. So then 1 reaches its position 1, 3, 4, 6, 8 by the time the left part of the subarray is sorted. Then 9 and 5 will remain. 9 is, by the time 9 will be greater than 8, so no swapping is done. We keep on moving to the right. 5 will be swapped with the 9 because 5 is less than 9. Then swapped with 8, so then swapped with 6, and once it reaches the position between 4 and 6, since 5 is greater than 4, no swapping is done. By the time 1, 3, 4, 5, 6, 8, 9 will be the sorted array. So like this the swapping continues. The algorithm first runs with a for loop. For loop starts from j running from 2 to length of a. So we concentrate on the second element, and ai is assigned to key. ai becomes the key. aj becomes the key, and aj has to be placed in its location on the left hand side part of the subarray, which is to be in sorted order. So what is that we're doing here is inserting aj into the sorted sequence for a1 to j minus 1, because up to j minus 1 it is sorted and jth element has to be placed in its corresponding location. That's how the algorithm proceeds. Starting from j minus 1, the index will keep on moving lower down to 1 ultimately. So while I greater than 0 and ai is greater than the key, we keep on swapping. So ai plus 1 is we keep on moving, ai plus 1 is equal to ai and so on, and once it reaches its corresponding location, it comes out of the while loop, and then ai plus 1 will be assigned to the key. So in the first part, in the first for loop, we'll keep on assigning each of the elements as a key to the while loop. In the while loop, we'll place it in the corresponding location after swapping if required. That's how the algorithm proceeds. If we look into the best case, if the given array is in the sorted order, so what happens is, starting from the second element, it will be compared with the previous one. It's already in the sorted form, so we keep moving. So every element will be compared with the previous one, and comparisons are necessary, but we cannot avoid them. But swapping is not needed in case of best case. So in any of the cases, comparisons are cannot be avoided, but swapping can be avoided. So in the best case, if the array is already sorted, no swapping is done, and until we reach the last element compared with the last element, then we'll stop. So that becomes the best case when the given array is already sorted. And obviously the worst case is most number of swappings are required apart from the comparisons. If we need to swap almost all the elements, it becomes the worst case, and obviously it is the case where the array is in the decreasing order, and you need to keep it in increasing order. So we need to swap almost every element. And the average case obviously lies between the two. If average number of swapping operations are required, then it becomes the average case.